Hi everyone, this is a new video on oxygen not included, and today we'll see how to produce oxygen. So there are different designs well known within the community, and this one is the half Rodriguez. So with that being said, let's get started. So before going through the design itself, it is important to understand how gases work, because we're going to use the electrolyzer, and the electrolyzer produces hydrogens and oxygen. And the oxygen is heavier than the hydrogen, so the way the mechanics works in the game is that if a gas is heavier, it's going to go at the bottom, it's going to go down, and if a gas is lighter, it's going to go up. So this is what we're going to see now. To illustrate that mechanic, I'm going to use an empty room. So here I have a room that is empty of gases, and we can verify this by activating the gas overlay, and we can definitely see that this room has no gas in it at all. So what I'm going to do, I'm going to fill the bottom of the room with hydrogen and the top of the room with oxygen. So that way we can see that the hydrogen is going to try to go up and the oxygen is going to try to go down. So I'm going to fill half of the room with hydrogen, and now I'm going to fill the other half with oxygen. So yeah, we're almost there. And so we can clearly see that half the room is filled with hydrogen and the other half is filled with oxygen. And now I'm going to unpause the game, and we should see that the hydrogen is trying to go up to reach the top of the room, and the oxygen is trying to go down to reach the bottom of the room. So I've just unpaused the game, and we can see that indeed the hydrogen is trying to go up and the oxygen is trying to go down. So I'm going to speed up that process to see the final result. I've waited a little bit longer, and we can now see that the situation is completely reversed. We have all the hydrogen at the top of the room and all the oxygen at the bottom of the room, so they have both switch sides basically, and this is what we expected, because the hydrogen is lighter, it's at the top of the room, and because the oxygen is heavier, it's at the bottom of the room. This design is probably not the most efficient design in order to gather gases, because if I put let's say gas pump here, so I'm going to put multiple of them, and I try to gather this hydrogen rapidly, I'm going to also gather oxygen, and this is not what I want. I would want a way where I don't need to gather the oxygen, but it's going to be a little bit complicated in that manner. So if I unpause the game now, we can see that it's releasing, it's pumping the hydrogen, and then it's going to start pumping oxygen as well. And it's not easy to differentiate these two gases in that manner. The following room has a slightly different shape. It has less space at the top of the room, so in that way we can have a greater concentration of hydrogens here at the top of the room and a smaller concentration of oxygen here at the bottom of the room. I filled the room with the two different gases, the hydrogen and the oxygen, and we can see that at the top of the room where the hydrogen is, there is a greater concentration, so it's about 800 grams, and at the bottom where there's the oxygen, there is a smaller concentration. In that way it's easier to control the gases, and there is less chance that the oxygen comes at the top of the room where we don't want it to come, because we only want to pump hydrogen. Now that we understand a bit better how the gases work, and especially these two gases, oxygen and hydrogen, work together, we can take a closer look at the electrolyzer. Because the electrolyzer is going to consume 1 kilogram of water per second, is going to consume a bit of power as well, and is going to produce both oxygen and hydrogen, but it's going to produce more oxygen than hydrogen. So in order to do that, I'm going to run the game, and we'll see that this electrolyzer, it was in the vacuum room, and it's producing both oxygen and hydrogen. So naturally the hydrogen is going to go at the top of the room and the oxygen is going to stay at the bottom of the room, but there is way more oxygen than hydrogen. Now that we've seen how the oxygen and the hydrogen interacts between each other and what the electrolyzer does, we can take a look at the half Rodriguez design. So here there are quite a few things to go through, but first we have two electrolyzers, and we can see here that we have airflow tiles. This is to allow the oxygen to go down here that are going to be pumped by this gas pump, and the hydrogen is going to be pumped by this gas pump here at the top. So the idea is that the hydrogen is going to be pushed here on the top, and the oxygen will not be able to be pushed here because we have this manual airlock. So given that the oxygen is heavier, is going to go down, and only the hydrogen is going to be able to go up that manual airlock, and then it's going to be able to go down again once it's here, because it should be filled only with hydrogen. The only problem is that at the beginning the room is not going to be filled with hydrogen and oxygen, so it's possible that there is a little bit of oxygen at the beginning. When you start running that design, it's possible that some oxygen will be pumped here, but after maximum probably a cycle, it should only be hydrogen. The next thing to look at is the atmos sensor. So we have one at the top of the room and two at the bottom of the room. And the one at the top of the room is meant to take the pressure of the hydrogen, because the hydrogen is always going to be here at the top, so we'll always measure only hydrogen. And two at the bottom, where we always only measure oxygen, because there should never be hydrogen at the bottom of this room. And these atmos sensors, they are connected to this gas pump. So if they don't reach the threshold of the pressure, these gas pumps are going to be deactivated, disabled, and they're not going to be able to work, and therefore they're not going to pump oxygen. And this is going to be the same for the one at the top. So, but the one at the top is meant to pump hydrogen. So that way we can ensure that we're not going to have hydrogen at the bottom of the room or oxygen at the top of the room, because we always make sure that we keep these two gases in the room. So we'll always have hydrogen at the top and oxygen at the bottom. Now that we know how the hydrogen is at the top and the oxygen at the bottom, thanks to these airflow tiles, these manual airlock, and these tiles here that block the oxygen to go back up, we might wonder, why do we have 4 gas pumps at the bottom and 1 gas pump at the top? And that has to do with the production of the electrolyzer, because the electrolyzer produces 880 grams per second of oxygen, and we have 2 of them, so that's about that's more than 1,500 grams of oxygen per second, and these gas pumps are only able to pump 500 grams of gas per second. So if we had only 3 gas pumps, we wouldn't be able to pump all the oxygen, because it produces more than 1.5 kilograms of oxygen per second. That's why we need a 4th one. And at the time we need only 1 gas pump for the hydrogen, because the hydrogen is only the electrolyzers only produces 112 grams per second of hydrogen. So multiply by 2, that's definitely less than half of a kilogram, and therefore 1 gas pump is definitely enough to pump all that hydrogen. I am now going to go through all the different overlays, and I'm going to start with the power overlay. So here we can see that I've used a connective wire that is able to handle up to 2000 watt. So I could connect all the machines together with a single wire, but if you were to use the simple wire, so which is that one that can only handle up to 1000 watt, you wouldn't be able to connect all these machines together. You would need to split the machines that you connect together into 2 different wires, because this wire is only able to handle 1000 watt, and we have a current power and a potential load of 1440 watt, which is over 1000 watt. That means that your circuit would overload at some point. The next overlay we're going to see is the plumbing overlay. So it's pretty straightforward. We can see here we have a depth pump in order to get the water, but in a real game you would need to get the water from another source, but it shouldn't be too hard, and we just inject that water in these 2 electrolyzers, and that's what the electrolyzer needs in order to work. It needs water and power, so that's just basically it. We'll now take a look at the ventilation overlay. So this one is pretty straightforward as well. We have 4 pumps at the bottom that are going to pump the oxygen that we just eject here just next to the room, but you would probably want to use that oxygen for your colony, so you would probably try to eject it in your colony. And at the top we have a gas pump that is going to pump the hydrogen, that here one more time we're just ejecting it next to it, but it can be used to generate power, and we'll see later how to do that. But basically you can use it to generate power and in order to make all these machines in that room function by themselves. The last overlay that we're going to see is the automation overlay. We've already kind of seen it very quickly, but basically we just use these Atmos sensors to enable or disable these gas pumps for the oxygen at the bottom of the room, and we use one as well at the top of the room to enable or disable the gas pump for the hydrogen. So far we've seen how the half-Rodriguez gas works. We've seen how it produces oxygen and hydrogen, but we haven't seen how to power the half-Rodriguez gas and how to use that hydrogen efficiently. So we could power this setup by using the hydrogen. So it's self-powered, so that means that it produces enough hydrogen in order to power all the machines that it contains. Just at the beginning you will need some power in order to spin up the setup. So in order to do that, in order to use that hydrogen, we will use the hydrogen that is pumped from the half-Rodriguez gas, and we're going to inject it in 2 hydrogen generators. We need 2 of them because it only produces 800 joule per second, and we have more than 800 joule per second that is consumed in our half-Rodriguez gas. So in order to provide enough power to the half-Rodriguez gas, we will need 2 hydrogen generators. And these 2 hydrogen generators are connected to a small battery, so it can store that electricity, and it's also connected with a wire, an automation wire. So when the battery is full, these 2 hydrogen generators will stop working and they will not waste any hydrogen. So now how do we spin up that setup? Well, any source of power will do it, but we can just use a switch, and here we're using the def generator to simulate any kind of power source, and we can just switch it on or switch it off, and that way it will spin up the setup. So here we can see that the hydrogen generators are working and are filling the battery. So now I'm going to simulate that we are spinning up the half-Rodriguez gas, and so that's what it will be. So now the battery is full, and we can see that these 2 hydrogen generators have stopped. Now that we've seen the different overlays, it's time to talk about the limitations, and the first one will be heat. So these 2 electrolyzers, they both produce heat. They both produce 1.25 kDTU per second of heat. That means that little by little this room is going to get warmer and warmer. So it's not going to get outside of the room because we used insulated tiles, so the temperature outside of the room should remain the same, but inside of the room is going to get hotter. And the problem is that if we don't use the right components here, it could break. So here I have an electrolyzer that is made of copper ore, and that one is made of golden almanac, and now I'm just simply going to increase the temperature, and we will see that it's gonna be problematic. I've sped up the process, and we can see that the room is way hotter now. It's about 80 degrees here at the top right, and it's about a little bit less, 78, 79 degrees at the top left of the room. And we can see that this electrolyzer is fine, but that one has overheating damages. So if it continues a little bit more like that, it's going to be completely broken, which means that you need one of your duplicants to get in the room in order to repair it, and it's not sustainable because it's gonna keep doing that, because it's gonna keep overheating. And the reason why that one is broken and not the other one, or is going to break and not the other one, is because that one is made of copper ore, and copper ore has overheat temperature for that device of 75 degrees. So if we look here, we can see that it has an overheat temperature of 75 degrees, whereas the other one has an extra 50 overheat temperature. It's 125, and that has to do with the material used. It's using golden almanac and not a copper ore. So golden almanac has an extra 50 degrees before having damages due to the temperature. a high temperature. So all these devices, they should be made of golden almanac if you don't want to run into this problem. Otherwise, it's going to be tricky to get a duplicate in, and then you'll have to deal with the hydrogen eventually getting out of the room as well. The heat is going to cause other issues as well, because now not only the room is hot, but also the gas that you are ejecting is going to be hot as well. So the hydrogen is hot at 80 degrees, but usually it's not that important because we can use it to produce electricity, power, and it doesn't matter if it's hot. But the oxygen is different because you want to usually reinject it in your base, and therefore it's going to travel within your base and it's going to make your base hotter, and your duplicants might not be happy and your crops can stop growing. So for that reason, this is gonna cause some issues. So that's why this is important to build this kind of setup close to this kind of machines and anti-entropy thermal nullifier. This allows to create cooling, and this is going to help to cool that gas that is going out of your half Rodriguez. Another issue you could encounter with this setup is if you have an excess of hydrogen or oxygen. So how could you get that? You could get that if you simply, for example, are not able to release all the oxygen from your pipes. So that would stack up here, and then it could affect the stability of your gas pressure in the room. So you could have oxygen starting to mix with hydrogen, and therefore you could start having oxygen mixed with your hydrogen when you pump it out. And if you use it with generator, hydrogen generator, that could break that generator and do damages to it, and then you would need your duplicants to repair. So that would be inconvenient. So how to solve that issue? Well, the first one is pretty simple. You can make sure that you don't have any excess of oxygen or hydrogen in your gas pipe, that you always consume or release all the gas that is produced, and therefore you keep the stability in your room with between the oxygen and the hydrogen, and you're not going to encounter any problem. But usually we don't expect it, so that's the problem. So the other solution would be to use a gas filter and to only filter the hydrogen. So usually we have the problem with the hydrogen and less with the oxygen, but you could do that with the oxygen as well. The only problem is that it's going to add an extra cost, and the cost is 120 watt per second and per gas filter. So that's going to consume more electricity. Let's now talk about the production and how much duplicants it can support and how much power is going to generate. So here, if we start with the power consumption that is needed, we can see that it requires 240 watt multiplied by 5 plus another 120 watts multiplied by 2. So that's 1440 watts that is required in order to run that setup. For the oxygen, a normal duplicant would require 100 grams of oxygen per second. So that's what they would breathe in every second. But there are different traits. So some duplicants can have a buff or a debuff, and they can consume more or less, but we're just going to assume that they consume 100 grams per second per duplicant in this case. Now let's take a look at the production. So if we take a look at the electrolyzers, we can see that it produces 112 grams of hydrogen per second. So if we multiply that number by 2, that gives us 224 grams of hydrogen. And with that hydrogen, that means that we can produce 1792 watt of power. Let's now take a look at the oxygen, and we can see that the oxygen being produced is 888 grams per second per electrolyzer. So given that we have 2 electrolyzers, we have to multiply that number by 2, which gives us 1776 grams per second. So with these numbers, we can already work out how many machines the hydrogen can support and how many duplicants the oxygen production can support. But these are theoretical numbers, so now we're going to see if they are correct, if they are practically correct. To verify these numbers, I run this setup for a full cycle, and I then just gather all the gases and make the calculations to see how much of each gases we collected. So for the hydrogen, I collected 212 grams per second. So that means that it produced 1696 watt per second. So it's a little bit less, but it's very close to the number that we expected. And for the oxygen, we collected 1685 grams per second, which is also pretty close to the number that we expected, even though it's a little bit lower. We can therefore conclude that this setup can power all its devices, and it even has 256 watt of extra power after it powers all its devices. And it can support up to 16 duplicants because it generates 1685 grams per second. So probably you want to be a little bit safer and probably go to 15 or 14 just in case you have duplicants that consumes more oxygen or they have a debuff, but it can support up to 16 duplicants.